The purpose of this video is to teach you how to find the pH of a weak base solution. Weak bases are different than strong bases. With strong bases, it's obvious how the bases increase the concentration of the hydroxide ion in water. There's hydroxide right there in the formula. But with a weak base, you have to remember, and I'll use ammonia, the weak base acts as a proton acceptor with water, and so the hydroxide actually comes from the water, and we'll have in this reaction, for instance, ammonium plus the hydroxide ion. And again, this is just a equilibrium problem paired with an acid-base reaction. These are straightforward like the weak acid problems with one extra step. In the weak acid problems, we were solving for the concentration of the hydronium ion. Here in weak base, we're finding hydroxide. So in a weak base problem, our x will be hydroxide, and so the negative log of x is not pH, rather it's pOH. For our sample problem, we'll be finding the pH of a 0.85 molar solution of ammonia. Ammonia is a weak base with Kb 1.8 times 10 to the negative fifth. This is an equilibrium problem, so I will need a balanced equation so that I can do an ice table. Ammonia plus H2O, remember H2O is a liquid, is in equilibrium with ammonium plus the hydroxide ion. This is a 0.85 molar solution of ammonia. Don't care about the water, it's a liquid. 0, and again we're going to say that that is 0 even though we know there's hydroxide in water. Just like a weak acid, minus x, plus x, plus x. I love it. It never changes. And we'll get 0.85 minus x, x, and x. As we continue, we'll go back to our equilibrium expression, and we'll get that x times x over 0.85 minus x is equal to 1.8 times 10 to the negative fifth. This is a small Kb value, so we probably have a negligible x down here. We'll try it and hope for the best. If it's not negligible, we can always go back and use the quadratic equation, but we'll say that this is x squared over 0.85. I like to remind myself, I'll say that x is equal to, remember, this is the concentration of the hydroxide ion. That's important for our last step. That's equal to 0.00391. I'm going to do a quick check for whether or not x is negligible, and I'll do 0.00391 over 0.85. That was my initial concentration. And I find that this is 0.46%, so that checks out. Remember, anything under 5% ionization is negligible x. So back to the problem at hand. If I take the negative log of x, remember that's finding pOH, not pH, and in this case my pOH is 2.41. Just another quick reminder, this tells me the power of 10, and these are my two significant figures, and that will give me a pH of 11.59. 11.59 makes sense because that is a basic pH.